get started. Thanks.
There's the bell. Should we give him a minute? Oh, I'm sorry. We're going to do a mini hack for a second.
Oh, you don't have to change anything. Yeah.
B. How did you do that? B?
B or V?
Yeah.
B for
B.
black.
B. B.
You can also do
What will they think? What will they think of next?
right.
Okay.
W goes white.
Huh?
I think they changed anyways. Maybe not.
Okay. So, Damon, we're going to start with Ashley saying a few words. Okay. So thank you for coming back. We are going to now talk a little bit about some of the prizes for the mini hacks. Ashley.
Thank you, Susie. Hey, so just wanted to let you guys know we forgot to mention this earlier. You can, if you do, excuse me, if you do 2 mini hacks, you can get 2 prizes. So you can get a fidget cube, for your kids, or to self-diagnose ADD, and a really cool bottle opener. So like bartender bottle opener. So just if you do that, a couple mini hacks, then you can earn these things. So thank you.
Yes, so you do get prizes for mini hacks. Excellent. Okay, so starting up for our next one, I think that many of you have come here to see Damon. So Damon will be speaking next on self-service operations because failure still happens. Damon, so many of you know him because he's really one of the luminaries for DevOps. And just starting out, what does DevOps mean? How do we all work this? And we know it's still under development. Damon is a co-founder of Rundeck, so scheduling and orchestration platform. Prior to this, he was managing partner at DTO Solutions, where he's looking at DevOps and IT operations management. He spent over 15 years in the industry, working both on the technology side as well as the IT side of things. And then he's been really active in growing the international DevOps community. So he's a co-host of a few things you guys are probably aware of, the DevOps Cafe podcast. You guys like that? DevOps, yep. As well as an early organizer of DevOps Days. DevOps Days, awesome. And then also, he's a content chair for Gene Kim's DevOps Enterprise Summit. So very active. Also, he's the father of a 3-year-old girl, and we were just exchanging potty training tips. I have a 2-year-old. And he practices DadOps, which we'll hear about next, in addition to DevOps. Thank you, Damon.
Thank you. All right. I always get a little embarrassed when someone says the word luminary. As long as it's not charlatan, I'm okay. So how many of you are developers, by the way? Okay, all right, that's good. I was concerned, because I have a developer version of this talk, an ops version of this talk, and a boring, down the middle talk. So this is the developer version, so good. I'll hopefully be speaking to you. And the talk, we get to the point of self-service operations, but it's more about how do we, as developers, how does developers help? I say we, I'm more of on the operations side. How do developers help operations help them, right? Especially in large organizations, ops happens, and we have to deal with it, and as things start moving faster, how do we make it in a position where it doesn't come back on the developers, and developers can do what they need to do? So that is the point of this talk. Who I am, thank you very much for the introduction. But the point is, so today I'm one of the co-founders of Rundeck. We're an orchestration and scheduling tool vendor. Used to be the managing partner of DTO Solutions, which was a kind of specialist DevOps and operations improvement consulting organization for a number of years, also heavily involved in the DevOps community. And the point of all this is, through all this, I get to see a lot of companies. I get to see inside, what works, what doesn't work, from small kind of high-flying web startups to huge multinational financial services conglomerates. I get to really kind of dig in and see what's happening, what's not happening, and how they respond to this new desire to go faster and do more with what they have. So a lot of this talk is about what I've learned through that and these design patterns that I'm seeing develop. So there's this dream we're all being sold, right? It's in every booth out there, right? It's going to be deploy, 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 deploy. That is the idea. We're going to deploy 5 times a day, 10 times a day, 1,000 times a day. It's going to be amazing. You just put your headphones in, you lock in, and you're just going to code, hit commit, and life is awesome, right? The reality is that we still live and work in big, complex organizations, right? That there's multiple parts, there's multiple generations of technologies, multiple APIs we have to deal with. There's a complex world we're in and around us, and operation still happens, right? There's another four-letter word I can put instead of ops there, but stuff still goes wrong, right? And it's not ops' fault, or it's not just ops that gets called into this, right? As developers too, you know what this is: escalations, the interruptions, the delays, waiting for things, all the context switching you have to do. Oh, I did that last month. Now you're asking me a question about it today. It's finally in production. Like what's that? The bridge calls. Who's been on a bridge call lately? Yeah, who really enjoys being on bridge calls? Anybody? No? Right? Maybe. Okay. Yeah, the arguments, right? It's so this the reality collides into our dream. So I'm going to start with a story kind of that's related to this. Anybody ever bought some through Ticketmaster? Yeah, no, this is right. So $25 billion, good to know booing or hissing. They're actually great guys, and they try, they do a good job, but everybody wants the tickets. So Ticketmaster, it's like $25 billion a year in ticket sales globally, right? It's a huge global operation. Talk about legacy, a huge chunk of that goes through mainframe code that was first checked in 1976, right? So, and they've got all the new high-flying stuff too. They've got it all, right? A dozen different ticketing systems around the world. It's actually quite an amazing thing to see it work. But a few years ago, they realized they have a problem, right? Now, when Ticketmaster has a problem, this is not TechCrunch news, right? This is New York Times news. The Yankees can't print playoff tickets, right? This is a big deal, right? People around the world can't get their Adele tickets. That's on CNN Global, right? So they realized that in this complex dance of things that they have to do to keep all these fans happy, they've realized that their incidents are taking way too long, right? They had an average MTTR, mean time to resolve a repair, 47 minutes for major web incidents, right? And if people are already angry because they can't get fast enough to get those Adele tickets, imagine what those 47-minute outages feel like in that world, where they're creating these Black Friday events every time they do an on sale. So three folks who key in this story: Jody Mulkey, their new CTO at the time; Justin Dean, the new head of technical operations; and Mark Mon was one of their key system engineers who helped put this together. And before the Support at the Edge program, said 47 minutes. After the Support at the Edge program, they put into place without changing the underlying technology. They got their average mean time to repair from 47 minutes down to 3.8 minutes. Right? That's a 90% reduction in MTTR. From a developer perspective, it's a 50% reduction in escalations. Right? So half of the time people get interrupted. Let's stop doing that. And from the business perspective, over half reduction in the overall cost of support, right, that they had to do. So, and this is story's about a year or so old, so I'm sure they're even better now. So, would you like to know how they did that? But first, let's look at the principles behind this improvement, right? Because let's see sort of how it came together. So, first of all, if you think in the industry, right, there's two schools of thought you're going to see when it comes to operations support, right? There's the classic, you build it, they run it, right? Someone's going to create something, I'm going to throw it over the wall with some instructions, maybe some scripts, hopefully not some SharePoint documents, but it could be. I'm going to throw it over the wall to the operations team, and they're going to deploy it, run it, manage it for me, and take care of it, right? Then there's this kind of a newer school of thought, right? We call it the you build it. The first one was the you build it, they run it. We call the next one the you build it, you run it. Right? This idea we're going to have integrated development teams, we're integrated delivery teams, we're going to put all the right dev and ops people together on those teams, and they're going to crank, and they're going to stay in that same context, and they're going to do the full life cycle, right? Build, release, operate, update, so on and so forth, right? And I know Amazon's kind of popularized this idea of the two pizza team, right? Which is, hey, we should have these small, tight, integrated teams, and no team should be bigger than what can be fed by two large pizzas, right? And if you're a lot of systems administrators, maybe they're extra large pizzas, but you get the idea, right? So, but let's talk about the problems of these, right? There's pros and cons of these. On the you build it, you run it side, The idea that, hey, someone else is going to do this stuff for us, right? Isn't that going to be great? We can be rock stars and stay focused in on our development, right? But you know what happens, right? Well, it's 2 a.m., right? The knock calls, they want you to talk them through, bring something back online, right? So you teach them to go through the health checks, looking at log files, the process of diagnosing and then recovering the system. It's the same thing you did for QA or other development teams 2 months ago. You did it for QA last month. You did it for operations last week. You know you're going to have to do it again. And you finally, it's 3, 4 in the morning. Everything's back online, and you go back to bed, right? Then you're at the office. You're a little groggy, but you're cranking. You feel good. You're going to get what you had to get done for the day. Phone rings again. It's ops, right? Hey, we're going to take down EU West. What's that going to do to your application? We changed some firewall rules. What do we have to do to your application to make it work? So on and so forth, right? So more interrupts and more interrupts. So the dream of someone else is going to handle it never really came true because you have all the context that they need anyways. So the rest of those teams really call them the escalators, right? It's just something goes wrong. We're going to draw a box around what it possibly could be. We're going to escalate off to them. So it's not really, that dream's not really coming, the labor savings isn't really coming true. Then there's the other problem is, which is a lot of focus in the DevOps community. If you throw things over the wall to somebody else to run it, you're inherently going to have the handoff problems, the gaps in context, and you're going to have quality problems, right? And then our service blows up, right? So that's the other problem with the you build it, they run it. So now let's talk about the you build it, you run it, right? It's great if I'm a single purpose, kind of startup, right? But what about in the enterprise, right? Well, what happens invariably when companies try to do this, I got this team, they have project-based funding models, right? Not product-based funding models. So things are funded in projects. So I just end up with a lot of different services that I'm creating, and these integrated teams, pretty quickly it's like, well, from one quarter to the next, I'm working on new things. I'm building new features over here. I've got an incident for something I did before. You start to get all these different things you have to keep going. The project-based funding goes on, and we start to run out of teams, so people get more and more and more services, and eventually it breaks, right? And and people say, well, this is easy, right? You guys really like that fire thing. I'm going to use a lot more of that in future presentations. But so everyone says, let's just change the business, right? Why don't we just? Well, yeah, sure. If you talk about the Amazons, the Netflix of the world, it was a business decision to structure their organization this way, right? So if you can change how your business is structured, funded, and operated, then good on you. I think this is a great model to go for. But most large enterprises, it's essentially impossible to go to the business and say, we need to change how we're structured, funded, and run in order to make this model work, right? So how do we get the best of both of these models, right? We want the labor scaling benefit of the you build it, they run it model, right? But we want it without the frequent escalations and without the bad handoffs, right? Those breaks in context. I want the responsiveness and control of the you build it, you run it model, but without the scaling limitations, right? So self-service operations is this name we've given to this design pattern that we've seen pop up in the community. It was there in the Ticketmaster story. We see it in Equifax and other places as well that are talking about this. How do you straddle the old and the new in a large enterprise? And it's basically the idea of how do we address those places where the handoffs need to happen between different parts of the organization. And the key idea, if you think about how automation used to work, it was operations' job to define it, to execute it, to have all the security and management and auditing and control over it. What's interesting about the design pattern is these companies have taken those kind of 3 essential parts, the definition of the automation, the ability to execute the automation, and all the management, security, control of the automation, and they've split it up into different pieces that can be moved to where they're best used, and where they can best exploit the workforce capacity or the labor capacity in their organization. So kind of cartoonishly, it ends up looking like this, right? To say, well, on one side here, we have the gap, we have the producers, people who make something that somebody else, or do something that somebody else needs. In this case, we're probably talking about ops, right? On the other side, we've got the consumers, right? The people, the developers that need ops to do something for them, right? So what they end up doing is saying, well, let's, again, think about that definition, execution, management, control, right? Well, let's allow, in most cases, let's allow the producers to define the automation policy, operations define the automation policy, let's give the consumers, the development teams, the ability to execute that automation, right? And then let's have another operations or security team keep kind of watch over, well, who can run that stuff or what? And then it's like, well, wait a minute, we have this capacity problem in operations having to write these procedures for things that somebody else develops. Why not give that to them too? So let's let the developers write define those automated procedures, hand it off to operations who can vet it, then turn around and give the execution back to development if they want, or give the execution to internal kind of operations support teams, right? So they can kind of play with that mix of those three controls and have a common place to collaborate on defining, executing, and controlling that automation. And then they move that kind of toggle back and forth based on what they're trying to do. Is it for the new web stuff? Is it for the old legacy stuff? Where do we have the most labor capacity to spare, right? That's kind of the core idea. So, you're like, okay, it's great for operations, but what do developers get out of this, right? Developers in the room. Number one, it's this reduced escalation and quicker resolutions, right? You hate getting interrupted. I mean, think about Agile, Kanban, Scrum, all these things. What's the whole point? Not being interrupted, right? You set up your whole world to lock in and not be interrupted by, or have too many things going on at once and not be interrupted by other things, right? It's like one of the core ideas of all this Agile stuff they've been talking about for the last decade. So all this operations work coming your way is just going to interrupt things, things more. So the old model, it's like, well, we're going to have this, sort of some network or some operations team. They're essentially what we call the escalators, right? Something goes wrong, they got to find the right people, and they're going to say, what's wrong with your service? What's wrong with your service? Your job is to log in and say, not me, and get back to your other work, right? So by the time something actually, transpires that you need to look at in operations, you're too busy, you're too late, right? And you're always behind the gun. In this newer model, if we're able to have, use the self-service operations idea to have these, predefined procedures to move that labor to where it's best utilized, you can keep a lot of those escalations off of your level, layer 2 and level 2 and level 3 support people, right? The specialists, the developers, help them define those procedures, let the operators be operators. It takes a lot of the pressure off of the developers, right? Also, it gets you tighter feedback loops, right? And the whole DevOps movement is all about saying, how can we, make these faster feedback loops between development and operations? If you're, as a developer, have part in defining these procedures, you can run them, you can see them being run, you're much tighter integrated to the operations process, you get better feedback, which helps you create, better systems, which improves operational performance in the future, which means less interruptions for you as well, right? And also, this may not make as much sense without talking about what I want to talk about later, but this self-service operations design pattern really helps change the mindset of operations managers, right? In the old mindset, when they're the ones that have to do all of the work, their whole job is around, or most of their job is around protecting capacity, right? We don't have enough people, we got too many tickets flying our way, so it's all about protecting capacity and saying no, right? Get the hot potatoes off our plate and don't let any more in. If they have the team focused on building these self-service operations capabilities where they can relieve some of that pressure, the mindset turns into more of a service provider. Hey, how do we scale this service we've created? How do we get more users to use the service we created? So if they're thinking more about how am I more useful to you, the consumers of my service, than they are about that bunker mentality. It's really an interesting shift that developers will find much more friendly than the kind of traditional ops, go away attitude, right? So how can developers help operations make this a reality, right? How can you help them get involved with this? So first, we want to understand, the pain of operations today, right? I think you got to walk a mile in their shoes to understand what's going on. First, operations is in this kind of horrible squeeze, and there's a lot of pride in the operations world that they don't want to admit this is going on. But if you think about all this DevOps, digital transformations, it's all about going faster, opening things up, go, right? And this is coming from the highest levels. The business is pounding this, or is beating this drum, right? But then on the other side, they have all the traditional operations concerns. It's be more secure, be more reliable, don't be the next hack, don't be the next breach, lock things down. This is, keep us off of, CNBC, right? So and ops is in the middle of all this. They're getting squeezed. It's often the same business folks that are making these pressures kind of on both of these sides, right? And ops is the place where they have to handle that, and the traditional procedures aren't scaling. And at the same time, it's always the classic on ops, like, spend less, do more, right? The cost pressure is squeezing as well. So ops is in this tough position of getting squeezed. So anything you can do to talk to helping relieve that squeeze is going to go a long ways. If whatever you're suggesting is going to make that squeeze worse, you don't have a prayer. Which is why a lot of times, the kind of core enterprise operations resistance to these DevOps and agile and digital transformation ideas is quite resistant because they're afraid of that squeeze. And think about ops too. Again, I talked about development, that you've done all these things over the last decade to lock out change and to limit work in progress and focus. Ops is unplanned and planned work by design, right? So you have to take that into account. And we've already talked about on the development side how toxic this unplanned work is, but they accept it by default and have to layer it in with planned work, right? Maybe not at an individual level all the time, but definitely at the organizational level, you got to manage both. And we know how expensive context switching is, right? This is why we want to lock out all those changes in the agile world, right? There's a guy named Gerald Weinberg who Jeff Atwood, the coding whore guy, H-O-R-R. He, to be clear, there's a code of conduct somewhere. He's kind of broken down some of his work and made it digestible. Talks about the cost of context switching. That they think it's 20+% loss of productivity for every additional project you add to somebody's workload, to the point where the context switching is actually more of your cognitive power than actually doing the work, right? So ops is dealing with this. Ops dealing with crushing technical debt. This is actually a real healthcare provider. I mean, talking about, just to get changes done, right? They got 900 developers, 500 people in QA and app support, 200 in operations. They've got all these other things they've bought in the past: billing, pharmacy care, patient care, government services, right? And to make a significant change, I think it was just to allow people to see their bills in different regions of where they're working. This is all the pieces they had to touch, right? Just to get a change done, because it had to go through the new UI, the old UI, the mobile teams. They had to talk to the back-end mainframe folks. They had to get the operations people on board. They had different operations for different markets because different customers wanted different things, right? And this is the life in the operations. It's probably like if you go and talk to Cisco folks, go talk to the folks at Cisco WebEx versus a new sort of a chat streaming startup you talk to. It's two different worlds, right? So be aware of that technical debt. Silos are the other thing that ops is deals with, and we all have to deal with, actually. And silos aren't just we have different teams, but it's the break in context, right? So the idea that I'm in my group and we have a shared context and we have a common work queue, right? That's our silo. And the other somebody else, they have a different context and a different work queue, right? And that's their silo. Maybe there's multiple teams in those silos, but generally they're single team or kind of one group. And the problem with these silos is we have these breaks in the context where work has to pass from one to the other, right? So this is very much the classic DevOps type problem where devs working in their context, ops working in their context, and this is where we have these feedback and handoff problems. Operations is generally a whole big series of these, right? So they've got networking silos, which I'm sure you all know about, right? They've got servers, they've got storage, they've got the new cloud teams, right? They've got the network operations teams, they got the firewall teams, they got everybody, right? So silos everywhere, let alone the silos of dealing with the different delivery teams. And so, we're often told, oh, well, just cross-functional teams, right? This idea pops up again where we're going to just layer in all the people that we need on these teams and divide it up in sort of these cross-functional groups. But the problem is, it's never enough, right? Especially remember that big picture of the crushing technical debt in the enterprise. There's never going to be enough of these cross-functional teams to go around. You're never going to have enough network specialists or enough DBAs or enough security engineers to go around everywhere. So you're going to always have these other silos that work has to jump from one silo to their silo and get done and then come back. And that's one of the key points of the self-service operations design pattern is that how can they let these cross-functional teams in the new model, get all the goodness that they need from this specialist team without having to actually hand the work off to them? How do I make it something where I can pull it as needed and it doesn't get in my way of these teams? So one more thing about operations that I think you have to understand, that the silos way of working plus this evolution of new tools means that we're always going to have what we call these islands of automation. We see it everywhere, right? You're going to have Ansible, Puppet, Chef. You're going to have PowerShell scripts. You're going to have old shell scripts. You're going to have legacy automation tools sitting right next to your brand new fancy tools, right? You're going to have all the new container stuff. And these things are erupting all the time. I mean, you talked 3 years ago, Chef and Puppet were the hottest thing in town, right? Now in a lot of organizations, it sounds funny, but it's almost legacy, right? I mean, it's the new advanced project team that was making that stuff happen 3 years ago. They're on to the new Kubernetes, Docker, and Chef and Puppet have moved on to the core group, and they got to figure out, well, how do I deal with this, right? And so every 3-5 years, you're going to have a new wave of tools, a new wave of things happening, and ops has to deal with all of that, right? So that's something to keep in mind, that islands of automation are a reality. We have to embrace that and help them deal with that, not expect that we're going to have one tool to rule them all, and if they just saw it was better, then they should change everything they do. You just can't do it. Again, that crushing technical debt, silos, all of those things. So we want to embrace that. So from the ops perspective, the stuff we just talked about, squeeze between competing pressures, planned and unplanned work, silos are everywhere, crushing technical debt, islands of automation means they have no time for anything, right? There's never enough people, there's never enough time. This is the pain of the people that you're going to be going out and talking to and saying that you want them to do something different, right? So how developers can help operations, right? Number one, recognize that great operations starts in development, right? You guys heard that expression that abs, your abs aren't made in the gym, they're made in the kitchen, right? This is that same idea, right? That, I can exercise all I want, probably should do a lot more, but if I, keep eating pizza, it's just not, what's the point, right? So as developers, we need to take that on and realize that, hey, it's our responsibility. In doing that, we have to develop with this operable first mindset, right? And I'm going to kind of blow through this quick. It's like a whole other presentation. I'll blow through it kind of quickly. Number one, realize that operations is the business, right? Unless you literally sell packaged software, right? You are not in the software business. Your company does not get paid to write software. You get paid to run and deliver services. So operations is by definition the business. We have to keep that in our minds, that everything we have to do, the operability of it is key, right? The deployability, the configurability, the monitoring, they're all features of the service. Without them, the service does not work. The service doesn't work, we're out of business, so the service has to work. There's all first-class features as important as any business function that you're going to be developing, because the service is the business, right? Build configurability into the service. Don't externalize it. Don't say, well, I'll have a configuration file, or well, if you just use this, this framework to do X, Y, and Z, then you can configure this thing. The configurability and the monitoring and the deployability are all part of your service. Build the configurability into the service. Give them another page to configure it through there. Give them an API to configure it. Don't externalize it and make it operations problem. Demand prod-like environments everywhere, right? The ability to say, as developers, you really hear your operations pushing for, I want to, this kind of the more aware operations organizations will try to push and say, hey, I want to get developers developing against prod-like, may not be exactly prod, but limit the number of differences between production and these development and testing environments. But the reality is development should be demanding that. Because again, if you're concerned about the deployability, the configurability, the operability, all that matters is what happens when this thing runs in production. So why aren't we developing against as production-like environments as possible? And making sure that all of the deployability, configurability, the monitorability, all of that stuff is working as early as possible in those environments, not wait for it to happen some other place. Make sure that handoffs and teams are verification driven. Again, they don't have time to catch these Word documents with do this, then do that, or if you check this log file and look for for it to be 2 dots, not 3 dots, then that this this thing is functioning properly. Try to make this as test driven as possible. That hey, run this script to see if it works, to make it run. Press this button to see if it's functioning properly. Build that verification into what you do. Just really get in the weeds. Create immutable version artifacts and use standard packaging, right? The container, the Docker, whether it's the Docker containers or we're talking about RPMs, come up with a consistent way to distribute and package and build something once and then configure it for different environments. And last one, which developers always kind of groan about, but integration tests over unit tests, right? From a developer perspective, unit tests are king, right? But that's for you. That's for you to do your job better. Integration tests are what matter to the rest of the organization, including operations, right? Because for them, it's, is this service running? Is this service healthy? That is the single most important test. And often those are the tests that we always forget about until, oh, write those in the end because you're busy worrying about the unit tests. Unit tests are incredibly important, but that's for your own craft. It's for your own team. It's for your own use. What matters to the organization, what matters to operations, is the integration, black box style tests to know, is this thing working with the things it needs to work with, and is this thing healthy and happy? If there's any test you're going to have to the rest of the organization, not to you, the rest of the organization, that is, the test that matters, right? And so in that, the reason why we want this operable first mentality is to shift left. Have you heard this term before? This is kind of big in the DevOps world. Let's shift left as much of that operations activity as possible. And in the kind of common way, a lot of people talk about, well, there's the deployment type activity, right? There's the automated tests, deployment automation, security scanning. We can pull that forward, but also think about how do we run this stuff post deployment, right? So automated runbooks, monitoring metrics, operational control. How do we pull all that as far left as possible and solve those problems in development when they're cheapest and easiest to solve? You solve those in development, you won't get woken up as much. The lifecycle will move faster. You'll see what you're doing come out in production a lot quicker. You'll have much tighter feedback loops, and you'll be a lot happier. Kind of fourth thing you can do is, all right, taking these mindset, taking these ideas, start to develop these self-service operations capabilities. And how we've seen it come about is generally this kind of multi-step process here. The first thing we see people do is establishing some kind of secure operations hub, right, or something called an operations portal. It has really two elements, right? One is the activity and health view. How do I know this environment or this service is healthy? How do I know what the configuration is? Make that visible where people can see it. Being from Rundeck, we see this a lot where people use Rundeck, either the open source or the pro version, as the centralized place to define those automated procedures, right? It allows them to say these are my standard operating procedures, and then define the security policies and the data policies for those procedures. And then with that, it can say, well, now I'm going to start to let different operations team use these standard operating procedures, makes them more effective and efficient. I'm going to start to let different engineers give them some limited self-service access. Maybe they can run anything in pre-prod, but in production, they can only do this kind of safe restart and some kind of deep status command, right? Excuse me. And then down below here, at all times, security and operations manage access. They manage configuration, compliance, all that good stuff. They stay in control. Again, we were able to now we have the ability to move execution and control where we need it. But the next part I always come to is, well, how do we make the definition part better? How do we get all that stuff into this portal? If we still have to rely on operations to set it all up, we're just going to run into that capacity crunch again. So taking the same SDLC-driven approach that we're seeing kind of very popularized with infrastructure as code and the whole DevOps movement, do the same thing for your monitoring and setup and your automated procedures, right? So put them in a source repository, do code reviews where security and operations and development can look at it and say, yeah, this looks good, thumbs up, thumbs down, and then promote it when ready into that common place. Then they always get to, well, hey, we got all this other information. We got all these tickets, right, everywhere. How do we get that information integrated? Other monitoring, this new kind of software supply chain ideas of, where these artifacts, the control of the artifacts, that can be, folded in as well. And by doing this, they're able to sort of orchestrate and take most of the operational activity in the organization, break it up into those different pieces, and move it to the people that need to see it. Makes compliance happy because now you've got the who, what, when, where, everything, the audit trail. It's great. So, those are kind of the four things that developers can do to help operations. Back to our Ticketmaster story, so I only got a couple minutes. What they did, again, didn't change the underlying technology. Number one, they came up with the idea to say, let's have the automated ops procedures. We've got a standard vocabulary. Let's let these be written and vetted by the delivery teams and handed off to operations. Ops would accept them, maintain full control over what can run and the security policy. They empowered the NOC team to no longer be escalators, but actually start to take on support tasks. They embedded a lot of these tasks into their monitoring tools. So when you get a monitoring alert, no longer did you have to look in a book and figure out who to call, but actually gave them links to their, to the automated procedures to resolve the incident, especially the known ones they already knew about. And they empower developers these limited self-service operations. To some teams are doing deployments, other teams is just to take part in remediation, but they're able to move that around. And then they came up with a new incident response and escalation model to kind of help wrap this and fit this into their culture. And that's the kind of the nuts and bolts of what they did. I'd be happy to talk about it more in depth afterwards. But again, it wasn't an underlying technology change. It was a change in the process and the supporting tooling. And I think it was about 18 months or so. I could be wrong about that between these two, from 47 minutes to 3.8 minutes. So here's my talk in one slide. Probably could have just showed this. But remember, understand the pressure on operations, right? Understand the operating model that you're in and the pros and cons. Develop that operable first mentality amongst you and your development peers. Shift left is many of those concerns. It sounds like more work in the short term on you, but trust me, you're actually making your world and the entire organization better, and your life will be much happier. Apply that self-service design pattern, operations design pattern wherever you can, not just in the sort of dev and ops, but maybe between DBAs, network engineers, and the rest of the teams. Anywhere you have specialist activity and you want to scale it, we see it be a very popular thing to do. And make that explicit investment in the process and tooling to make it happen. Don't just expect this to happen on its own, but look at it as a formal project and a formal thing you want to do. And that's my talk. If you want to talk to me, I'm Damon at rundeck.com or at Damon Edwards if Twitter is your thing. I'll also be here. Thank you very much to the DevNet crew for having me, and enjoy the rest of your day.
Great, that was awesome, Damon. So that's a big move, big paradigm shift from DevOps to self-service ops. Great. Okay, so, you want your laptop?
Great job. That was a fantastic talk.
Great. So next, we're going to call back up Mandy Whaley. So, you've seen a little bit about her throughout this. Mandy's awesome. So she's on my team. Hired her in as our Director of Developer Experience. She manages our entire Dev Evangelist team, as well as what we call the sandbox. The sandbox is if you're kind of coding on top of some of our products, you want a running version of those products without necessarily having to go out and buy a router to do network automation on routers. So we have the routers in our sandbox. So there's so much that she's done. She's a teacher at heart, so she was actually teaching in college before that. And then she's also been teaching software to all of our CCIEs, to our Cisco certified internet engineers out around the world, to our SEs. So she's really brought together software together with infrastructure and applications. And then she has a really interesting talk that she's given on the power of DADOps for women in tech. Well, I'll just let you judge for yourself, but super important message for all of us, not just for dads, not just for women, so for all of us. Thank you, Mandy.
Thank you. Can I get 12 minutes on the clock? I know we're trying to catch up, and I'm going to do this lightning style quick. I've done it as a 5-minute lightning talk before, so we'll see how it goes. So this is a talk. It's the power of dad ops for women in tech, and of course it's really family ops. I love the dad ops hashtag. If you haven't ever looked it up, give it a look. But it's dads who are active a lot of times in the DevOps community and things that they're doing with their family. And it's really the DevOps community, actually DevOps Days, I'll give a shout out to Damon and that community, who inspired me to give this talk, because it was through conversations with that community that it came together. So this is about things that dads, uncles, neighbors, teachers, moms, aunts, family in the very broadest sense can do to help increase the number of women making it into STEM careers and into STEM technology. And So I'm going to dive in. So I started thinking that I really want to talk about women in technology, and I want to do it for a couple reasons. One is that I want to do it for my company because I think that diverse teams are better at solving problems. I want to do it for all the amazing women on my team who are finding their way in their career. And I want to do it for these crazy kiddos. So I have 2 sons, I have 4 nieces, and I want tech and STEM to be a really diverse and exciting place when they get there. So it's partially for them. But when I start to think about talking about women in tech, I don't ever do it. I get blocked by all of these topics. I think it's so big, it's so complicated, I'm going to leave that to the experts to talk about. Or maybe it's a little too close, a little too personal. I think it'd be more fun to talk about containers and Pythons and API, which is what I normally talk about. And I'm a lot more comfortable talking about that. It feels like a minefield. I'm probably going to unintentionally offend someone. So many pieces. Where do I start? I'm a developer. I don't know anything about these kinds of problems. Why would I talk about it? And then what assumptions will people make about me when I do talk about it? So one night I was explaining all this to my husband about how I had all these reasons why I wasn't going to talk about it, and that was probably the really smart thing to do. And he looked at me, he's really good at challenging me, and he said, I think you're being kind of lazy. And I was like, oh. And he was like, if that was a technical problem, if that was a business problem or a technology you wanted to learn, none of those things would stop you. He said, you are a woman in technology. You have 2 engineering degrees. You've worked in a number of different engineering fields and you found your way to software development and you love it. If you're not going to talk about it, who is going to talk about it? And he was right. And it was so annoying. I was like, oh, it's true. So I decided to give it a try, and I'm figuring out how to talk about it. So I really want your feedback. I'm trying to learn and iterate and figure out how to have this conversation. And so this is based on my personal story. It's certainly not scientific, but I think giving these stories is helpful. So who in the audience is a dad or an uncle? Awesome. Who has maybe a neighbor or a daughter or a son or anyone that they feel like is interested in STEM and you're kind of interested in shepherding and building that fire within them? Yeah, awesome. So that's why I give this talk, because it's usually the case that the audience has quite a few people having those thoughts. So all of you have some special powers. There was a great study that found that 68% of girls who are interested in STEM had a father or a male champion who encouraged them to go into STEM. And fathers and other male champions of change are key factors in the participation of girls and women in STEM fields. And I thought this was really interesting. But then I kept reading it, and something was bothering me, and I thought, encourage. Encourage is kind of a fuzzy word. What does that mean? Encourage how? What, just encourage someone? That's really enough? I don't think so. So I decided to think about what are some specific ways that dad ops and uncle ops and mom ops can do this encouragement. How can we make encourage more actionable? And so this comes down to some things that my dad did with me. So there's 5 of these. We'll go through them quick. The first one is develop an engineering mindset. So this is the idea of what we do in our jobs every day. How often do you exactly know how something works and you do it and it works exactly that way? Never, right? That's not the way technology works. And so developing this mindset of you try something, it doesn't work, you learn, you iterate. This is the most important thing. You have to teach your kids to deal with the unknown. And I have dads ask me all the time, should I teach my daughter Python? Should we start in JavaScript? Is Scratch the right place to start? And I always tell them, the language doesn't matter, the technology doesn't matter, it's this mindset that matters. Like learning to have this engineering thought process is really the most important thing. And unfortunately right now, school doesn't teach this. School is predictable for the most part. Schools are doing more things that are more open-ended and teach some of this. But really, it's predictable rules and defined outcomes, which is not the world of technology and STEM. And so I think it's really important to try and build some of this technology mindset at home. This is my dad. He's awesome. He's a lawyer, and then he also went back and became a doctor, and he's had a million hobbies. He is a serial hobbyist. He goes from one hobby to another and dives in very, very deep. All these things, most recently, he's on ukuleles. He plays at ukulele. He goes and speaks at ukulele conferences. Did you know that was a thing? It is. He's like on the ukulele concert circuit. So when he was about maybe almost 70 or 60 something, he decided he wanted to make a website about ukuleles. And so he learned HTML and JavaScript and CSS when he was like 68-ish, and he built a website. It's kind of a weird looking website, but he did build it himself, and he interacts with people all over the world about ukuleles through his website. And what's great about all these things that we did is that he gave me examples of learning something new. I knew that yesterday he didn't know anything about telescopes, and now we're in the middle of trying to build one, and it's kind of a huge disaster, but we're finding our way forward, and now we have a working telescope. And he always brought me into that learning. He did not let me sit on the sideline. It was come over here and solder this wire, help me do this thing. Now, I have to tell you that this was not always popular with me as a teenage girl or whatever. There were tears and resistance, but he persevered through, and it was just part of our family culture. And I think it has really led me down the path towards engineering. So, show the fail. When you're doing projects, a lot of times, we just want to show the pretty end results. We'll show the house that's put together. We didn't show that really there were a bunch of missing parts and we had to like wire tie it together and super glue it. Show the process with your kids. Show them, what happened and how you backed out of it and how you recovered. It doesn't have to be a physical thing like home repair, although that's a very rich vein of things like this. But like cooking, my cooking is all fail, so I can easily share that with my kids. All right, the next one is owning technology starts with the technology at home. So think about all the technology in your house. What technology do the kids in your house own? Own in the sense of they troubleshoot it. They figure out when it's not working. They patch it. They keep it running. They are the people in charge of keeping that technology working. Sometimes it's not very much. And so I have a story that goes with this. So when I was in 3rd grade, I told my dad I wanted a stereo. And I said, I really want, all my friends had these cute little shelf units, and I wanted a stereo to listen to my awesome 3rd grade music, whatever that was, like Rock Me Amadeus or Stray Cat Struts or, all those amazing things. And so I wanted a stereo, and my dad said, yeah, I'll get you a stereo. And here's what he gave me, a stock of components and a box of wires. And I was like, it's not what I was picturing. And I was like, okay, great, can you go set it up? And he was like, you go set it up. And I looked at him like, what? And he's like, yeah, go set it up. So I took the components back to my room. I took the box of wires. A stereo is not that complicated, right? There's not that many ins and outs, and most things are labeled. So I was able to figure it out, and I got it hooked up. I don't know why my dad did that, if he was like really amazingly observant or if he was just tired that day, didn't want to set it up. But it was kind of magical, because from the time that I did that, I knew how that stereo went together. I could take it apart, I could move it around my room, I could look for which wire was causing it to like sound funny, I could add new components. I owned that stereo, and I took care of it, and I could add to it. And even to this day, like I'll go try to help with the AV stuff if it's not working. So I had a lot of confidence around, I understand how this goes together, and it's because I just did it on my own. But we have way cooler technology in our house now than stereos. We have all these things. We have Alexas, we have PlayStations, we have our computers. I just got an IoT lock. We have thermostats. So I would say find something that your kids care about and let them be the sysadmin for it. So my older son, he's 12, he is the sysadmin for all gaming systems in our house. He's got the on-call for that. When something goes wrong, that's his thing. And he's not really very interested in the wireless network, but when the PlayStation doesn't work because it can't connect, he is interested in the wireless network. And so we have a conversation around how do you troubleshoot what's going on with the router and what is all these things that are happening. And it's been very powerful for him to kind of take control of that. We recently got one of these IoT locks, and he set it up himself. I gave it to him. He looked it up on the website. He put it in the door. He loves it. He unlocks it with his phone. And it's great. But the only side effect is he's the admin for our house lock now. So I probably need to update that. But this is a very powerful idea. So find the things that happen in your house. And I've had some great people from these conferences give me some feedback. So here's a kid. His dad gave him a box of wires and a switch. This other one was from James, governor from Oktoberfest. And he said, I wanted to get my daughter her own computer. Now I'm really frustrated. And then later on, he sent me back, We got it working, and my daughter's like, it's my computer, which I definitely want to make a sticker that says, it's my computer for all the kids to have. Then there's some more. These were from DevOps days. So let your daughter fix the router day, which I think is a fantastic idea. This kid put together his own drum set. And then actually Ashley Roach, who was on stage with me earlier, he's doing a whole series around teaching my kids Linux, which is pretty cool. He has 2 daughters and has been experimenting with that. So I love to see this. If you guys try anything, please contact me on Twitter and let me see how your projects are coming together. All right, the next one, debate with your daughter. So this one's really important. You can debate about anything. Pick something that is passionate but not too sensitive. Like my dad and I would debate around Scrabble rules. Is P really worth this number of points, you know? And we would get into these heated debates. It can be about music, it can be about Star Wars predictions, you know, things like that. But debate, have a real debate, a real exchange, and listen to what she's saying. And what this helps with is if she chooses to go into STEM, at least for now, she's probably going to find herself as the only woman in a meeting at some time. And she's going to need to stand up for her ideas and her thoughts. She needs to be confident and comfortable doing that. And I really think that practicing that at home in a friendly environment really helps. My team might think that I practiced that a little too much. But, but I think it's really important. I think this woman in a meeting meme is ridiculous. I'd love to end it. But it's real. You know, you do see it. Okay, this other one is, it's okay to break away from the pack. So this is where the encourage part comes in. Right now, if you're going to choose a technical field, you're probably making a choice that some of your other friends aren't making if you're a girl. And a lot of times in middle school, where this sort of pack mentality becomes really powerful and everyone's kind of doing the group think, that middle school time period is also the same time when you might need to pick to go to a different summer camp or to take a different math class or to sign up for a different after-school activity. And so I think knowing you have the support and being encouraged to do that makes a tremendous difference at that particular point in time. So I love this definition of encourage, to inspirit, hearten, embolden, to mean to fill with courage or purpose, strength of purpose. And so if you have a daughter, a niece, a friend who is interested in STEM, please embolden her with that courage and strength of purpose to go ahead and try some of those things that are different. And the last one, this one's really hard. So you have to have that important and really uncomfortable and kind of awkward talk with your daughter about calculus. So this is so important. So if you take nothing away, this is really a really important one. So I recently read this study, and it says that women are 1.5 times more likely to leave STEM after calculus as compared to men. And the lack of mathematical confidence is a suspected culprit. Lack of mathematical confidence? What does that mean? Is mathematical confidence a thing? Do you need confidence to do math? I mean, you need it to maybe speak or do something, but so I started looking into it. It's a very, very real thing. Like there's documented studies that if you have confidence in your mathematical abilities, you perform better, and it makes a big difference. And so I dove into this study a little bit more, and I think there's some things that we can do. So I know this is small, but I'll walk you through it. This is basically the drop-off of girls and boys starting from 4th grade all the way until entering the STEM workforce. So in 4th grade, it's roughly equal, and then there's some drop-off over as they make it into middle school. Then in middle school, there's a very steep drop-off, and it's much steeper in girls. Boys stays, relatively constant. Then there's a very steep drop-off in both, although steeper for girls as they get from being a freshman in college and continuing on in the STEM majors, and then we continue on into the workforce. So if we look at that very steep drop-off, this is really interesting. They surveyed all the people leaving Calculus 1 that did not continue to Calculus 2. So Calculus 2 is like required for most engineering, computer science majors, right? And this red line, it says, I'm not taking Calculus 2 because I do not believe I understand the ideas of Calculus 1 well enough to take Calculus 2. They didn't fail. They totally had grades high enough to go, but they chose not to because they didn't think they knew it well enough. And if you look at the statistics, only 14% of the STEM intending men chose that answer, but 35% of the STEM intending women chose that answer. And this is why they thought that the culprit for people not continuing was mathematical confidence. And this really struck me because I thought, so they continued on and they said, what if we could change that? What if we could make those equal? If we could have the same rate of people continuing past Calculus 1, where does that put us? And that's this dotted line. And if we just shifted that one point, then we would have women making up 37% of the entering STEM workforce versus 25. So that's a huge difference in people entering the STEM workforce from that one data point. It is a constraint on the system, right? So can we do something to move that constraint around this mathematical confidence? I think yes. I think one of the things that we can do is have this awkward talk with your daughter. So I didn't have this problem with calculus. I liked calculus. But I think there were some reasons maybe why. We talked about calculus long before I got there. And my dad talked to me about it as it's a gateway. It's a gateway to majors that you may like. It's a gateway to careers that you may like. You may not like the class. It may be terrible. It may be hard. You may make a terrible grade. You may not think it's relevant to everyday life, but it's an important class because right now, the way curriculums are set up, it is a gateway. So I went in prepared knowing that. And I think that made a tremendous difference. And then the other thing is I've been recently having a lot of conversations about women that are freshmen in college kind of going through this and parents. And one of the things that stands out is that a lot of times the female students will get an 80, a grade of an 80, which is completely passing and fine, right? But they feel very negative towards that grade of an 80, that they're not performing well, they don't understand it, they probably should stop, right? And the guys are kind of like, I got an 80, I'm continuing on. Not to generalize too much, but that does seem to be a theme. And so I kind of dug into why. And so I think one of the reasons from the conversations I've had is that you're a freshman in college, you're away from your support structure, maybe you're in a major where there aren't a lot of other women, there's a lot of signals telling you maybe you shouldn't be there. And when you get a grade that's much worse than maybe what you got in high school, and you feel like it's not a good grade, it is amplified. The effect of that grade is amplified. And I've had women tell me, I got 5s on both AP calculus tests, but I never thought I was good at it. So far, I haven't met a guy that said that. So I think that there's like a difference in perception in the way that that is. So I would say, talk to your daughter, let her know calculus is important, and let them know that an 80 is fine, and then you're on to bigger and better things. One class should not determine your whole path, whether you can continue in STEM or not. There's many classes that make it up, so don't let that be a barrier. And then the other thing I think is we can share stories. How many of you had a hard math class that you felt stuck in college? Everyone, right? Do you talk about it? Not really, right? So share that story. And I've started a project called mathisnottheproblem.com. And if you would like to connect with me in ways that we can maybe talk about this, that we can share stories, that we can connect with college, you can go to that site. You can also just email me or Twitter me directly. But I am trying to gather collected people who are interested in working on this problem and think about what we can do locally within organizations that we're in, things like that. So the specific ways: develop the engineering mindset, own the technology at home, debate with your daughter or niece or nephew or friend, encourage them to break away from the pack if that aligns with their interest, and have the calculus talk. And that's it. I think we are going to wrap it up. My name is Mandy Whaley. You can find me on Twitter. I'd love to talk with any of you more about any of these topics. And thanks for listening.
What do you guys think? Awesome. Thank you, Mandy.
Yeah, absolutely. Oh, that's my computer. Oh, no, it's yours.
It's okay.
Yeah.
So was that a good talk to include in DevNet Create? Yeah? Okay, cool. Thank you, guys. All right, so that wraps up our keynotes for day 2. I want to, let you all go out to lunch, so you can go and have lunch now. We have mini hacks all afternoon, awesome set of speakers continuing this afternoon. As we said, you get prizes for doing the mini hacks. We actually have a link. We'll find a time to put it up later for if you want to join the project opportunity, so that we can actually be digging in, and we'll have a way to contact you afterwards so we can create the community around that. But thank you all. Have a great lunch, and I will see you around this afternoon.